So the early developing brain is especially vulnerable to insults from different anesthetics, which can result in long-lasting functional changes. The anesthetics sevoflurane and propofol primarily enhance the response to GABA. These anesthetics can also have additional and unique effects and mechanisms. However, the long-term changes after exposure to anesthetics during the neonatal period are not fully known. And so we investigated the changes in electrophysiological properties of the GABA-A receptors in adults that had undergone treatment with anesthetics at P7, and we then examined the functional correlates of these changes by examining behavior and scoring drug-induced seizures. So the experiments, we give the anesthetic, either propofol, sevoflurane, or ketamine, at postnatal day 7. We then return the pups to the mom and let them grow up for 2 months till they're adults, 2 to 4 months till they're adults. The electrophysiology experiments were stimulating the Schaefer collaterals and recording from the CA1 region in the dendritic region of the CA1. And what we record is the, this is an old, okay. What we record is the field EPSP, and it's an excitatory response shown here. And this is the untreated nocivo animal. This is the control. If we add muscimol, a GABA-A agonist, we obviously inhibit, and we get a smaller field EPSP. If we give sevoflurane at P7, we get a normal response at 2 months after the sevo treatment, but the inhibition is less. So we give the same amount of muscimol, but we get a greater excitation than we got in the nocivo treated. So there is a reduced response to GABA-A agonist. If we do the same thing with propofol, saline, or propofol at P7, we get a strong inhibition in both groups. So propofol doesn't inhibit it. Doesn't reduce the inhibition. If we look at ketamine, we also get the inhibition, and ketamine does not reduce the inhibition. We also did paired pulse. I was going to show that next to it, but these aren't the updated slides. So paired pulse inhibition, we show that there's paired pulse inhibition with sevoflurane P7 treatment. However, propofol, we don't get paired pulse inhibition. So neonatal exposure to sevoflurane, but not propofol or ketamine, reduces the inhibitory effect of muscimol on CA1 field EPSPs from adult mouse hippocampal slices. We then looked on, again, we give either sevoflurane, propofol, or ketamine. At P7, we look at adult mice, and we induce seizures with pentylene tetrazole. And we're inducing the seizures in the adult. We show enhanced, this is the control nocivo. When sevo treatment is given at P7, the adults show increased seizure intensity. This is not shown with either ketamine at P7 or propofol at P7. So neonatal exposure to sevoflurane, but not ketamine or propofol, increased PTZ-induced seizure intensity and reduced the latency to stage 5 seizures. And finally, we also looked at behavior. This is a 3-chamber experiment. Mice are generally social animals, unlike scientists who are less social. So the mouse would generally try and spend more time on the side with the novel mouse than on the side with the novel object. And so in the nocivo group, as you see, He spends a lot more time interacting with the novel mouse than with the novel object. However, SIVO P7 treatment, we found that they spent a lot more time interacting. They didn't spend more time interacting with the novel mouse than the novel object. So with SIVO treatment, we spend equal times in these chambers. With no SIVO treatment, he spends more time interacting with the mouse. Propofol, again, say the control spends more time with the novel mouse. Propofol, he still spends more time with the novel mouse. So P7 sevoflurane exposure, but not P7 propofol exposure, decreased the interaction with the novel mouse versus novel object. This indicates reduced social deficit with P7 propofol treatment. We also did some experiments where we had the mouse, a novel mouse, and our experimental mouse in the same chamber, and we looked for interaction between the animals, push crawling against it and following it, and sevoflurane inhibited that in adult mice, where propofol did not inhibit that behavior. So, in summary, neonatal sevoflurane but not propofol or ketamine treatment impaired GABA-A responses, resulting in increased field EPSP and excitatory inhibitory balance in adult mice. Neonatal sevoflurane but not propofol or ketamine increased induced seizure intensity in adult mice, and neonatal sevoflurane and propofol have distinct effects on GABA and seizure induction and behavior in adult mice. So even though both sevoflurane and propofol are both thought to be mainly GABAergic type anesthetics, they have very different effects on both long-term effects on GABA and on behavior and on seizure induction. And the work was mainly done by Daisy Lin and Jinyang Liu, and Jim Cottrell has been brought our interest into clinical anesthetic problems and why we study these things. Thank you.